Here's a video going over problem number 6 from section 3.2. It says match the histogram to the summary statistic given. So it looks like in the first one, the mean is 52 and the median is 52, and our standard deviation is really small. So whenever the mean and the median are the same, we're looking for a distribution that is symmetrical. And also, because the deviation is small, we're looking for a deviation that's symmetrical and that it does not vary that much. The majority of the data are very close together. And if we look over here, the range here is 10, the range here is 50, the range here is 60, the range here is more than all the others. So this would be the one. I would match this one with the 1. As far as 2, the mean and median are the same, so we are dealing with a symmetrical, and out of the remaining 3, it is the one with the least deviation, and so the least deviation would be, I'm leaning toward 2, this one going to 2, even though this one has a longer deviation, it's more uniform. It looks like in every case we're dealing with the mean and median is the same. So that's not really a problem. It really just boils down to the deviation. And if we look across the board, the one with the largest deviation goes from here. This looks like it's from about 0 to 120. So I'm gonna match that with the 4th one. Yeah, that looks good. And now we're going from about 25 to 82, and this one's going from like 30 to 83. So based on the deviation alone, I'm going to go with this one to be 2 and this one to be 3, and I'm going to just pray. I'm going to check my answer. It looks like we did get it right. Let's move on to question number 7. And this, it says, for each of the following data sets, decide which one has the higher standard deviation, if any, without doing any computation. Well, and so let's think about how is this even, oh, so it's like for part A we have to decide, is it set 1 or set 2. So what I'm going to say is the range between the high and the low is the same, 9 minus 1, but in terms of the majority of the data, they're right around the mean, which is around 5. This one should have a smaller deviation than the one in set 2. So I'm going to go with set 2 has a higher deviation. They don't want us to calculate anything, so that's my kind of problem. We just do it in our heads. They want us to do it as fast as possible. We could check our work, but that's not the exercise here. So we're really looking for which ones vary from the mean. Now, the mean is the middle number. If you were to average them all up and divide by 5, the middle number would be the mean. We don't know if it's 5 or not, but the mean is the middle number, and the standard deviation is a measurement of how far the data values vary from the mean. And so if I were to add all these up, I mean, I've got 10, 20, 25 divided by 5 is 5, and here if I add these up, it's 25 divided by 5 is 5. But in set 2, the data values vary. They're a little further away from the mean. So I'm going to go with set 2 as a higher mean. Let's look at part B. This time we're going from 6 to 15. That is only 7, whereas 60 to 150, that's a much further value. So I'm going to go set 2 has a higher standard deviation. And then finally we're dealing with this one. It looks like the numbers are very close together here. There is an outlier of 92, or 82. 82 and 92 are kind of far apart, but they actually average out pretty well. I mean, the average of like 82 and 92 is right smack in the middle, so they kind of cancel each other out. The other numbers are pretty close together, whereas here, it looks to me like the numbers are a little bit further apart. Like if I had to add them up and figure out what the mean is, I could kind of get an idea, but something's telling me that set 2 would have the smaller deviation. So I'm going to go with set. I'm going to go with set 1 here, but it's really close. They could almost be the same. But let's see, set 1 maybe. Okay, well, this time they actually turned out to be the same. That's actually pretty hard to compute. But it did look like there was some differences there. Like I have a 2, 5, 6, 8, 9, 12, and then 2, 5, 6, 8, 9, 12. So the numbers are kind of the same. Do you see that? How the ones digit, if you look at the ones digit, it's a 2, 5, 6, 8, 9. And this is in the ones digit, it's a 2, 5, 6, 8, 9. And then here's a 12. And this is equivalent to like a 12. So they kind of fooled us on that one. Learn from me on this. Don't make that same mistake.